Hey everybody, this is a little video about machining the spiraling head. I decided to start with this thing first because I thought it would be a good practice. And so you'll see, I just took a few snippets of video of machining this thing. I finished it, and tomorrow I'll go ahead and heat this up and cut the split cotter out, but I'm pretty pleased with how it came out overall. I still need to get some half inch by 3/16 inch cold rolled steel for the sides, the slides I should say here. And as I talk about in the video, I've decided to use a 5/8 inch straight shaft here for the top part, and ER20 collets. I think that would be very practical and useful. So that's it so far. If you'll stay tuned to the next few segments, it's probably just going to be a short video. Just took a few little snippets of machining this thing. And then the next thing I'll do, while I'm waiting for my spindle shaft to come, the ER20 spindle shaft and some proper cold rolled steel or tool steel that I can use for these arbors. The only piece of 5/8 inch stock I had is this brass here. While I'm waiting for that stuff to come in, I can go ahead and machine this tailstock as well. And I will keep you posted as I make progress. Thanks again for everybody watching, and I appreciate all the new subscribers and all the nice comments and that y'all are putting in. So thank you very much, and stay tuned for the machining sequences. Starting work on the spiraling head today, I've lined out and marked up a place for my split cotter to go. About to drill and ream a 9/16 inch hole for it. Got it all lined up. I used my little dowel rods that I centered, and I think I've shown how I do that on the surface plate to mark the offset and the place for the split cotter. Okay, I got it all drilled and reamed out, and this is the little split cotter blank that I made the other night. It's 9/16 brass on the outside and drilled and tapped for 5/16 24 on the inside. You can see it doesn't go all the way through. I'll have to finish that. The next steps will be to crazy glue. We'll take this out, clean it all up with acetone, and then I'll crazy glue this in place, and it'll just stay in place there until I'm done with all the machining, boring the axis. So again, this will be a 5/8 inch bore through the bottom, 5/8 inch bore through the top. Here, I can show you the what I use. If you've not seen me do this before, I use little dowel rods. I whittle them down or sand them down until they go to the inside, and I carefully mark as best I can where the center is, and I use that. I scribe a little line here along the outside, and then I scribe my offset and drill the hole there for these split cotters. Same thing here, although there's going to be a lot of machining on this part, a ton of machining to get that thing to look half decent. So pretty rough casting, but I think there's plenty there to take it off and clean it up neatly. It'll be fun. Looking forward to that. I will keep y'all posted as I go along. Thanks. Hey folks, thought I'd show the setup and explain what I'm doing here. This is for the spiraling head, and I first envisioned machining this the other way, but so far I've gotten both the front and back faces milled flat in the mill, and I'm just setting this thing up. As you probably saw or noticed in the earlier segments, this casting has a lot of irregularities on it. So my idea is here to set it up in the mill, and I'm just going to lightly clean up the top surfaces so that I have some good parallel spots. And sorry about that. What I've been doing is using this little alignment pin. Basically is what it is. It's a piece of 3/8 inch steel with a button on the end, and I've been able to run it back and forth along the side so there's no clearance along the side of the casting, so I know that it's as vertical as it can be. And I've tightened it up, and it's kind of inexact, but it's a nice way to make sure that you've got the alignment as good as you can get it. And I've also been using the square on top of a 1, 2, 3 block to get an overall eyeball of the situation. So that's the setup. In a minute I'll move this back down and machine those parts. The top parts I can machine with this. The sides I'll machine with an end mill along the side just to clean them up. And I'll bring you back to show you more about that. Here I'm making the final cut on the outside of the spiraling head, or the final roughing cut, if you will. What I've done is taken 20 thousandths of an inch of material off of either side, very shallow cuts. As you can see, I cleaned up the top of the casting here in these two places, and also cleaned up that side with the end mill, just like I just showed you. Okay, I've just finished boring the 5/8 inch holes, top and bottom, in the spiraling tool head, and came out really nice. You can see it's a nice snug fit on my 5/8 inch test bar. Plan is to use, I did it in the mill, that's what I wanted to show, and how I got the setup on some parallels. I have it resting on the back that I machined first. This bag over here is got a magnet inside it, and I'm able to brush the iron filings off into the bag it'll make cleanup easy. One thing, I'll show this when I get it ready, but I do plan on using a 5/8 inch diameter ER20 spindle here. There's a lot of different ways to do this, but I found on eBay a 5/8 inch diameter ER20 spindle, straight spindle shaft that I can use here, and I got for very inexpensive a set of ER20 collets. So I'll have that and be able to use that for this part of the assembly. The next things will be to take this out, and then I've got to mill the slots and drill and tap the holes. I'm milling the slot. This is the last cut. So I'll have to flip it over and do the other side. I think before I do that, I've got this side all clamped down, and this kind of Rube Goldberg contraption in the mill. I'll go ahead and drill and tap the hole for the I'll drill and tap the hole for the center of the slide there, and then I'll flip it over and repeat for the other side and do the top left. Okay, not much to look at here, but drilled and tapped the 1032 hole. Got the transmission in neutral, so I can just tap it by hand like this. Works out good. I'm using tap paste too. May do a little unpaid commercial. I do love this stuff. It's very handy for all sorts of stuff. I've used it on a lot of projects: aluminum, cast iron, steel, the whole shooting match. Good stuff. Alright, so there's the 1032 hole. Now to clean everything up, flip it all over, take careful measurements again, set it up, and mill the other slot on the other side. Oh, sorry about that bounce there.